This is a video key for the 6-1 and 6-2 CFA. So it says for problems 1 through 5, show what calculation you did to solve the problem and circle your final answer. So the first one is the measure of each interior angle. So notice it says interior angle of a regular polygon. So if I didn't tell you if it was regular, then you wouldn't be able to solve this. So a regular polygon, the measure of each interior angle is 172. Find the number of sides for the polygon. So if we did know how many sides it was, so if we did know n, say that's the number of sides, we would take that and do n minus 2 times 180. That would tell us the sum of all the interior angles. But then when we want to find out what each one is, if we divide them up evenly because it's regular, we would divide that by n. So unfortunately, we do not know the number of sides. So we have to work backwards. So I don't know what n is, so I can put it through this calculation, but I do know what the result should be. So I'm going to set that equal to 172 and just solve from there. I also showed some classes that you could have just said, oh, I know that the sum would be n minus 2 times 180. And then if you have 172 for each side, which there are n sides, the sum would be 172 times n. So you can set it up this way. And that is just the second step of this equation, because I would multiply each side by n to get there, because when you multiply each side by n, those n's cancel out times n, and you end up with the same exact thing. Then we can solve that. I do have another way to solve it, and I'll show you in a second. So once we distribute, we get 180n minus 360 is equal to 172n. We want to get the n's on the same side, so I'm going to subtract 180 from n from both sides and get negative 360. That's okay, because on this side we get negative 8n. And then we're just going to divide. So divide each side by negative 8, and that gives us 45. So this must be for a 45-gon. So the number of sides is 45. And we can always check our answer by running it back through the formula. So we could do 45 minus 2, which is 43. 43 times 180 is 7,740 divided by 45 is 172, so it works. Okay, so then the other way you can do this is after we learned about exterior angles. So if the interior angle is 172, then what would the exterior angle be? Well, remember they're supplementary, so you do 180 minus 172 is 8. So that means each exterior angle is 8 degrees. And we know that the sum of all exterior angles is always 360. So you could just do 360 divided by 8, which again gives us that 45. So that is a second way you can do it, and I don't care which way you do it. All right, let's move on to the next one. So find the exterior angle measure of an 18-gon. So this one's a little easier, just like the second way I did here, because we know that the sum of the exterior angle measures of a any polygon is a convex polygon is 360. So this is an exterior angle measure of a regular 18-gon. So we know that each of those exterior angles will be evenly distributed between each of those 18 exterior angles. So all you have to do is 360 divided by 18. And that gives us 20. So it is 20 degrees for each exterior angle measure of an 18-gon. All right, moving right along. Number 3, find the sum of the measures of the interior angles of a convex 63-gon. So notice I didn't say regular here because I don't need to say regular. I'm not looking for each of the interior angles individually. I'm looking for the sum of them, and that's always the same. So that is this formula up here, just that first part. So n minus 2 times 180 will give you that sum. So if we use our formula, n minus 2 times 180, what we know that n is equal to 63, so you just have to do 63 minus 2, which is 61. So I don't care if you just wrote 61 times 180, that's fine. Or wrote it out in the formula, but I mean, obviously that's the same thing. And then 61 times 180 gives us 10,980 degrees. So that is the sum of all the angles inside a 63-gon. So pretty big figure there. Approaching a circle. All right, next, find the measure of an interior, and that's had its repeated word, I'm sorry, of an interior angle of a regular 22-gon. So again, this time, I do tell you regular because you have to, otherwise you wouldn't be able to solve it. Of each a regular 22-gon, each interior angle, okay? And so we're going to do just that formula that we talked about already. So to get the sum, we do n minus 2 divided by, or times 180, then divide by n because we have to split each of the angle measures, the total sum of the angle measures, divided by the number of sides. So we get them distributed equally among each of those 22 interior angles. So we're going to do 22 minus 2 times 180 divided by 22. And again, you can just write 20 times 180 divided by 22 if you want to. Just be careful because sometimes I see people, because they subtracted here and have 20 here, they'll put 20 here. So pay attention. And then just do that on the calculator is fine. 20 times 180 is 3,600. So I'm just going to write out some steps here. So that you should have got 3,600 divided by 22 gives you approximately, because I told you to round to the nearest hundredth here, it's 163, and we get 0.6363. I think that repeats. So it's just 64 if you round to the nearest hundredth degrees. So that is the measure of each interior angle of a regular 22 gon. All right, moving right along for number 5. The exterior angle measure of a regular polygon is 12 degrees. How many sides does the polygon have? So again, whenever I ask you for exterior angles, it is the easier one to do because oh, I actually want to go back to number 4. There is a different way that you can do number 4. You can actually use the exterior angle if you want. So you can say, oh, I've got 360 degrees for exterior angle sum divided by 22. So 360 divided by 22 is about 16.37 when you, or no, sorry, 36 when you round it. And then that's the exterior angle. And then you can subtract that from 180. So 180 minus 16.36 will also give you that interior angle measure. So even if I asked you for the interior angle measure, you can, instead of doing this formula, you can just find the exterior angle, then find the supplement because that will be the interior angle. Okay, again, back to the number 5. So with the exterior angle measure, we know that the sum of all the exterior angles will be 360. So we're just going to take 360, divide that by 12 to see how many sets of 12 degrees, how many 12-degree angles can you have with 360 degrees? And that should be an easy calculation, should just be 30. So that would be a 30-sided polygon, so it has 30 sides. All right, number 6, find x, y, and z given the figure as a parallelogram, show all work. So remember, we were given properties of parallelograms, which I know it's a parallelogram because they told me right here. I can't assume. But we know that opposite angles are congruent. So I know that this angle is congruent to this angle. So I know that 4x minus 35 is equal to 2x plus 15. And then I also have the other set congruent as well. So I know these two are the same. So I know 15, no, not 15, sorry, 5z is equal to 3y. But there's a problem here. There's 2 variables. But that's okay because we're going to be able to figure out what either y or z is first, or we don't even really need this equation because not only do we know opposite angles are congruent, we also know that consecutive angles are supplementary. So there's lots of different equations you could set up here to solve. But the first one that we have to do is finding out what x is. So let's do this one. I'm just going to do same steps at a time, or a couple at a time. Subtract 2x from both sides, add 35 to both sides, and you get 2x is equal to 50 here, and divide by 2, and you get x is equal to 25. So we found one of them, and that's going to help us figure out the rest. So I'm just going to go ahead and plug it back into this one because I need that angle, or you need this angle. You need one of these angles to help us finish the problem. So 2 times 25, which we just had, was 50, right? 50 plus 15, 65. So this is 65 degrees. Oh, wait, if that's 65 degrees, so is this. So it doesn't matter which one we use. And we can check to make sure that works, right? So 4 times 25 should be 100 minus 35. Yep, that is 65. So that confirms our answer. Now I know that these two are supplementary, or these two are supplementary, these two are supplementary, these two are supplementary. So you can set that up to find y, set that up to find z, or you can find y or z and then plug it in here to find the other one. It really doesn't matter. I'm going to do 3y plus 65 equals 180. Because remember, they're supplementary, they're not equal.
I'm going to subtract 65 from both sides. And that will give me 115 is equal to 3y. Divide by 3. And that actually gives us a repeating decimal, so we're not going to write it as a repeating decimal. We're just going to leave it as either 115 over 3, or you can say 38 and a third. 38.3 repeating is not, you should write it as a fraction. Okay, you should leave it as a fraction when it's a repeating decimal, but for sure, absolutely not write it as a decimal without that bar. I will definitely count that wrong because, you know, it is wrong. With the bar, yeah, it's right, like correct number, but you should leave it as a fraction. All right, let's do our last one. So again, it doesn't really matter how you find it. I can plug, this back in. I can do 38 and a third times 3. So this 3y is equal to 115. So I can plug in 115 right here. 3y is 115, so plug it in here to solve for z, or I can say 5z plus 65 equals 180, or there's other ways we can solve for that. But I'll say 5z plus 65 equals 180. And then I'm doing that same thing, subtracting 65 from both sides. So I get 5z equals 115, which again is right here. 3y is equal to 115. I know 5z and 3y are the same, so I could have just started there. And then divide each by 5. And then let's see, 100 divided by 5 is 20, so 23. Z is equal to 23. And you can plug that in to make sure that it works to check your answer. And that's it for the first page.
I did change the audio that I'm using here, so I'm using a headset instead of my AirPods. Okay, so find the value of x in the polygon, then find the measure of angle D, show, setup, and work. So I just got all these angles inside, the interior angles, and I have a bunch of measurements. Well, we know we can solve this by, just like when we used to do it for a triangle, that the sum was 180, we need to just find out what the sum would be. So this is a hexagon, it has 6 sides. So to find the sum of the interior angle measures of a hexagon, we go through that formula, n minus 2 times 180. So that's just 4 times 180, which is 720. So I know all of these added up together are 720. Well, they're all just, a number, a coefficient with x, so I'm just going to add them up. So 7, 14, 21, 28, and then 28 plus 8 would be 36. So it's just going to be 36x is equal to 720. Divide by 36, and that's pretty easy calculation, but use your calculator if you need to. And so that's going to be 20. And so that's what x is equal to, but now I want the measure of angle D, which is this guy, so 7 times that, so it'd be 140. And you can always check your answer by plugging it in, making sure 140 times 4, because there's 4 of those, plus, 20 times 4 is 80, plus 160 would be 720. All right, moving on. Find the value of x, show, setup, and work. So this time we've got exterior angle measures. I have those pointed there. And we know the sum of all exterior angle measures is 360. So we just have to add these together and set it equal to 360. So I'm just going to do this to save some time. I'm just going to add up all the x's first. So I've got 2x, and I'm going to slash them as I go through. 2x, 4x, 5x, 6x, 8x. So that's 8 x's total. Now, it's a little trickier with the numbers, so I'm just going to write the numbers. Minus 13 plus 30. You can still do it in your head, but plus 8 plus 15. Sometimes we get messed up with the negatives and positives, so I'm just going to write them. Okay, now let's add them all together. So I know that you just got to be careful, okay? So this is negative 13 plus 30. That would give us 17. So that's 17. I put it there, 17 plus 8 plus 15, or let's see, 8 and 15 is 23, and then 23 and 17 together is 40. So it's just going to be 8x plus 40. Don't just copy down that minus. That's ridiculous. That goes with a 13. So it's 360 is equal to 8x plus 40. So just solve that. Once you get that set up, it is not hard, guys. So 320 is equal to 8x, and then we have to do 320 divided by 8. And that gives us 40. So x equals 40. And that's it for that one.
And again, you can check it by plugging it back in and making sure that all those angles add up properly. So I'm just going to do that for this one. We have 2x twice, so that's 80 twice. So that is for these two. I'm going to add that 30 that I know about. Then I'm going to add, let's see, this is x plus 8, so that'd be 48. This is 40 plus 15 is 55. And this one up here, 2 times x is 80. 80 minus 13 gives us 67. Okay, then I got them all. So in our calculator real quick, 80 plus 80 is 160. So plus 30 plus 48 plus 55 plus 67 gives us a grand total of 360. So it works. All right, moving on to the next one. Number 9, given parallelogram, so I'm told it was parallelogram, WXYZ, find A and B, cite the reasons, you can set up the equations. So this is where I'm having you cite your reasons. So to solve for B, I know that it's a parallelogram, so I know these two sides are equal. So I'm going to say, if parallelogram, opposite sides congruent. And that's all you need to say. You don't need to say, so then they're equal. We're not in a proof here. So we're just going to set them equal to each other. So 9b plus 8 is equal to 10b plus 1. And we also know the same reason for this other side. Okay? So for both equations, the reason is if opposite sides congruent, or if parallelogram, then opposite sides congruent. And then guys, this is really like some of the easiest equations to solve. So don't be rushing too much because there's no reason you should get these wrong. So we get 5a is equal to 10 over here divided by 5, and a equals 2, and you can easily check that. 2 plus 14 is 16. 2 times 6 is 12, plus 4 is 16. And then over here, this is so easy because you don't even have to divide. So subtract 9b from both sides, we get 1b. I'm also going to subtract 1 from both sides, and I get b is equal to 7. Again, we can check that real quick. 9 times 7 is 63. 63 plus 8 is 71. And then 10 times 7 is 70, plus 1 is 71. So we are good. So make sure you have that reasoning there. If parallelogram, you got to have that opposite sides congruent. And that's it for this page. Let's go on to the last page. All right, for number 10, it says find the coordinates of the intersection of the diagonals of parallelogram HJKL with those vertices. So you know it's a parallelogram. So we know if parallelogram, what do you know about the diagonals? Diagonals bisect each other. So if you know the diagonals bisect each other, you know that they intersect at their midpoint. So you just have to find the midpoint of the diagonals, or just one of them, and check with the other. So the diagonals will be HK, so you got to be careful here. So either HK midpoint, or you can find the midpoint of the other diagonal, and I'll just do both. The other diagonal is JL. And once you find those, you can compare it and make sure they're the same. And that's where they'll intersect, okay? So I'm going to do HK first. So HK, midpoint is just the average, okay? So average of the x's, so -1 plus 3 is 2, divided by 2 is 1. For the y value, then for the, for the x value, then for the y value, 4 plus -2 is a positive 2, divided by 2. Oh, look, it's 1, 1. How hard was that? And then I can check it using the other one, so JL. So I'm going to do the x's first. 3 plus -1, oh look, that's 2, divided by 2 is also 1. And then 3 plus -1, again, is 2, divided by 2, and that is 1. So that checks it off. So they intersect at 1, 1. So we didn't need to draw a picture. We didn't need to do any of that because we know that the diagonals bisect each other in a parallelogram. Therefore, their diagonals intersect at each other's midpoints. They share the same midpoint. All right, the last one is the proof. So I told you can't use any other conditions theorems. You only can use definitions and other theorems that we've learned about. So I'm going to go ahead and get this set up real quick. So we are given that it's a parallelogram, so that's the only thing we can use is that opposite sides are parallel. So I know it's a parallelogram. I can use that definition of parallelogram. So I'm going to go ahead and say that first because that's the key to getting all of this stuff here. PQ is parallel to SR, and we have that PS is parallel to QR. So that's by definition of a parallelogram. And notice we do have a diagonal given to us, and we're trying to prove theorem 6.8, which is that the diagonal separates the parallelogram into two congruent triangles. So you just have to prove that this diagonal makes these two triangles congruent. So you're just proving triangles congruent. This shouldn't be hard. You've done this kind of thing before. If I would have given you though that in the chapter when we did triangles, you would have been fine. I would have just told you opposite sides parallel. I wouldn't have told you it's a parallelogram, right? We can do the same things that we did there. So you can't say that opposite angles are congruent, okay? We're not using any conditions of parallelograms. Don't need them. So what we're going to do is we've got one part shared, right? So PR is congruent to PR, but we're going to name it. Notice that it is backwards here, right? So they're going to be P does not correspond with itself, and neither does R. So it's PR is congruent to RP, and that's going to be reflexive property of congruence. Then we've got that here. And again, we can't use any conditions of parallelogram, so we can't say opposite sides are congruent, right? So we just need to work with angles here. So we do have parallel lines, so working with angles is going to be super simple here. So I'm going to highlight. Let's do this. So these are parallel, so here's our transversal. Do you see the angles that are formed? Inside the triangles, so it has to be inside the triangle. So this angle and this angle are formed. So we know that those two alternate interior angles are congruent. So we've got angle SPR is congruent to, make sure you name it right, angle. So S corresponds with, we can look up here, Q, and then R and P do not correspond with themselves. So it's SPR and QRP. SPR, QRP are congruent by the alternate interior angles theorem. And that's due to these two being parallel. That's how we got those two. We had to have the other pair of sides parallel as well, because that would give us the other one. So now I'm going to highlight this one. So we use these two, and we're still using the same transversal here. But now do you see what angles are formed when we use this as a transversal? Or sorry, those as the two sides that are parallel? We get these two. Those two are the ones we get. So those angles are named angle QPR, and then we have to make sure we name the other one accordingly, angle SRP. So SRP, QPR. Again, we have the same reasoning, alternate interior angles theorem, but that's because these two are parallel. That's how we got that set of angles congruent. Now, if you look at it, we have ASA, right? So this is just this triangle rotated around. We have ASA to prove that those two triangles are congruent. So we've got it. So we have triangle PRS is congruent to triangle RPQ by the ASA postulate. And so that proves the theorem that if you have a parallelogram, that it cuts the diagonals cut the parallelogram into two congruent triangles. And we didn't need to use any conditions of parallelograms to prove that. And that was it. So it was just a short 1, 2, 3, 4, 5, 6, or 7, depending if you did 2 steps. Well, it's 5 or 6 if you put this all in one step, that would be fine. Or you might have split these up. Who knows? But that's it. And that will conclude the video key for the 6.1 and 6.2 CFA. Thanks for watching.